Okay, welcome back, everybody. We're going to take a look at working with parent-child components. As part of this, we're also going to take a look at what it looks like to start kind of building this thing out, right? As you add more components and add folders, you have to become familiar with the module system in Rust and how all of that works. So we're going to start to put together some of that stuff now. What I'd like you to do is in your source folder, go ahead and create a new folder called components. And inside of your components folder, I'd like you to create a new folder called parent_child. So create a source components, and then under components, create a folder called parent_child. Okay. Inside of that parent-child folder, I'd like you to create a new file called parent-child-home.rs. So parent-child-home.rs. We're going to build a component in here, and then we're going to wire that component into the rest of the application. So we're going to build a very simple component and then wire it into the rest of the application. So what I'd like you to do is type in use Leptos ;*. That brings in the all of the stuff inside the Leptos module, not all the child modules, but all in the top level Leptos module. We're also going to bring in, well, we're not going to bring anything else in at the moment. Let's just go ahead and add our component here first. And then we'll do our pub fn parent-child home impl into view. And then go ahead and set it up to look like this. There's my div tag, my h2, and then a little paragraph saying this is the parent-child home page is fine. So go ahead and add that component real quick. Okay. So we have this component, and we want to display this component on the main app component as one of the configured routes. How are we going to make that happen? The first thing that we need to do is we need to make the app component know about this component. And the way we're going to do it is like this. Inside of parent-child, create a new file called mod.rs. So mod.rs is similar to like an index.js file in Node or a dunder main file or more like a dunder init file kind of in Python. What this file is going to do, it's going to allow me to basically publish out this parent-child home module as part of this parent-child namespace. So I'm going to say pub mod parent-child home like that. So go ahead and add that code for me. Whoops, if I can remove the, I'm going to turn off Copilot for the time being. It's kind of annoying. And I want the stars to go away. All right, there you go. So put pub mod parent-child home inside of the mod rs. Okay, so now that we have a mod rs for the parent-child folder, we're going to do the same thing here for components. So I'm going to create another new file inside of the components folder called mod rs. So now there's a mod rs inside of components. And for this one, we're going to put pub mod parent child. So we're going to reference the parent child folder there under components. Pub mod parent child. Okay. Now what we're going to do is we're going to pull components into our librs file. See the librs file right here? Go ahead and double click librs. And at the top, type in pub mod components. So essentially, lib is referring to the components module. The mod rs in components refers to the parent-child module. And the mod rs in the parent-child refers to the parent-child home module, if you want to think of it like that. So we're kind of building up this tree of files for these various components that we're going to be working with. All right, so we have parent-child, which is inside of the source components parent-child folder. Mod rs inside of source components parent-child here. Then we have the mod rs inside the components folder, which refers to pub mod parent-child, and then librs, which is here. Now that we've got that integrated into the project, our next step is I want to be able to call that parent-child home. I want to be able to call that from my app rs. So up here at the top, I'm going to say use crate. So crate refers to the crate that we're inside of, the tools app project we're working on. I'm going to say components. Then I'm going to say parent-child. Then I'm going to say parent-child home. And then I'm going to put parent-child home. Go ahead and add that use statement to bring in our component. Okay. So now that I've got my parent-child home component there, the next step is I want to render this parent-child home component out. So the first thing we're going to do is we'll scroll down to the nav bar and let's add ourselves a new menu item. And we'll go ahead and set this to be parent-child. And then go ahead and put into the quotes here, parent-child. So add the new menu item. What's going to be cool about this example is we're actually going to do an example of nested routing here in a moment. But for right now, we're just putting in the initial parent route, and then we'll get into the nested routing. So parent-child. And then what I want to do is come down to the router, and we're going to say route path equal, and we'll say parent-child view parent-child. Oh. Okay. So go ahead and specify that for me, please. And go ahead and put a slash at the front of that too. Okay, perfect. So now we should be able to run this thing and navigate to parent-child home, and it should pop up on the screen for us. So once again, as a reminder to run it, we're going to do the Cargos Leptos serve. If your application's already running, hit Control C and start it again so it'll compile it. Give it a second to build here. Now, if I click on Open in Browser, I now have parent-child, and if I click on that, I should get parent-child home. I'll give you a second to compile and run it, and then we're going to set up our nested route. Okay. Next step in the process. We want to have, we're going to basically have 3 examples that we're going to look at. And those 3 parent-child examples are going to be available to us under what's called a nested route. So let's go ahead and configure the initial route nesting by doing the following. Update this route to look like this, so it's got an opening and a closing tag. And then what we're going to do is we're going to add a default route for this nested route. And I'm going to do that by saying route path equal view. I'm going to do the parameters for a closure. Then I'm going to say view $, or $, exclamation point. And then I'm going to have a paragraph, and I'm going to say click an example link, and I'm going to close paragraph and close the route. Go ahead and type that out, and I'm going to take a moment here to explain what this is. Okay, so this is a nested route. Essentially, when you go to /parent-child, it will display the parent-child home, but it's also going to display this additional view that we're going to add an outlet for over in parent-child home, but we have not added the outlet yet. We're going to do that in a moment. But when we go to add the outlet, we have to put a view in the outlet to be displayed. This is the view that we're going to be assigning. Now, what exactly is this? So if you're familiar with Rust, you'll know that this is what's called a closure. This closure here has no parameters, and this is the logic of the closure, which is just the view macro. What's a closure? A closure in Rust is basically a Lambda function in languages like C#, Java, Python, or if you've ever used arrow functions in JavaScript, you can think of it as like an arrow function in JavaScript. It's a Lambda function. I mean, it's in Rust, it's called a closure. Okay. So the square bracket, or not the square brackets, the pipes, that's where the parameters would be defined. And then the code that follows the pipes is the expression. So for example, if you were familiar with a language, let's say like C#, right? So let's say I have this function here. If I was to write this code, for example, and let's say something like JavaScript or C# or whatever, it would look like this. That would be the equivalent in a language like C#, JavaScript, Java. If you were to write this in Python, the equivalent would be lambda and then your expression there. This pipe syntax is a Rust thing. Also, I believe it's a Ruby thing too. I'm not a Ruby developer, but I believe the pipe syntax part of this actually comes from Ruby. So if you're a Ruby person, you'd be familiar with using the pipes. If you come from another language, that part might be a little bit confusing. You might be thinking of like an OR operator or something like that. But no, this is actually setting up what's called a closure. Okay. So down here, I'm taking this closure, which is really just a function reference, and I'm assigning that function reference to the view, which if you think about it, is all we're doing here, right? Parent child home is just a function. I'm assigning the function reference to view, and then when it renders, it invokes that function. Okay, so there's my default path. Now, in order to display this default path, I'm going to need to add an outlet to our home component. So if you could go to parent child home RS, remember that's under source components, parent child, and then parent child home. And then we'll say use Leptos. It's going to be use Leptos router. And then down here, we're going to replace this paragraph tag with what's called an outlet. So go ahead and update parent child home. If you'd like, go ahead and restart the server and run the code and see that the content from that view we created with the closure, verify that content appears in the outlet. Okay, now I'm going to come down to here, stop this and start it again. And then I'm going to pop back over to refresh this. And you can see, click an example link. Now, we don't have any example links yet, but you can see that content is being populated inside the outlet. So what do I want to do? I want to add some example links. So what I'd like us to do first is let's create a new component here underneath parent child. We'll say new file, and we're going to do parent child, and we'll do write signal.rs. So go ahead and add that file for me. For these demos, we are going to code them by hand. The temptation is to go copy them from the Tools app final, but I want you to see how these are built. Like, we're going to have explanation as part of building it. If you don't feel like coding it, you just want to copy the final solution, you can. But I am going to code these by hand. So what I'd like to do is let's just start off first by putting an empty component that we can then hook into our system and link to. And once that whole linking process is all done, then we'll go ahead and work on the content of it. So what I'm going to do is say use Leptos star, and then we'll do once again our component, and we'll say public function parent, and then we'll do our impl into view, and then we'll do our view macro, and we'll just call this our parent child write signal. So go ahead and add that code to our function for a moment, and then we'll wire the whole thing up. If you want to go ahead and update those mod files, you're free to do so. I'm going to do it myself here in just a moment. But if you want to go ahead and wire those up, you can. Okay. So now that I've got that component initially created, let's go ahead and open up our mods here. So I'll come into here and say pub mod parent child write signal. So go ahead and reference that module in the mod rs file for parent child. You should not need to modify the components mod rs because the components mod rs already points to parent child. You also don't need to update the lib rs because once again, the lib rs already points to components. However, we will need to import this parent child or this parent component in the app file so we can wire up the nested route. Okay, so I'm going to go ahead and open up the app rs here. We're going to scroll to the top, and we're going to once again say use crate components parent child write signal, parent as parent write signal. So go ahead and alias that for me because we're going to end up having 3 parent components that can't all have the same name. So we'll go ahead and alias that. So do parent write signal. I'm going to take this code and highlight it and come over to GitHub Copilot. And I'm going to ask it, how can I condense this code into one use statement? So it's going to offer me this option right here. So I'm going to actually copy that. Just a little example of using some Copilot here to maybe make things maybe a little cleaner, maybe not so much. But there you go. Okay. So I condensed it by going from 2 lines to 3 lines. You have to appreciate the humor in that. Okay, so there's my parent-child write signal. And what I'm going to do now is we're going to come down to the route here, and I'm going to say route path view parent write signal. And then for our path here, we'll come in and specify parent write signal. In fact, let's just call it write signal. and leave off the leading slash. I always put the slashes in the wrong place. So put the write signal there, route path write signal, view parent write signal. Now we're not quite done yet because we still have to add the link to be able to link to it, which we'll do in a moment. But go ahead and add that route to our route configuration. Okay. Now, we're going to come back over to parent-child home. And in parent-child home, we're going to set up a link to call this parent-child write signal component through the routing system. And the way we're going to do that is we're just going to put a little unordered list. We'll put a little list item here. And then I'm just going to put in a simple little anchor tag. And we'll just call this write signal. And for the href here, I'm going to say parent-child / write signal. And make sure you put a closing anchor tag on that. All right, go ahead and update your code. At this point, you should be able to run it, by the way. And you can, you should be able to click that link and it should display that in the outlet instead of the little message telling you to click the link. I'll run mine here in a moment. Okay. I'm going to go ahead and stop my server, start it again. And then I'm going to come over to here. Did it finish compiling? All right. There we go. All right, so now I've got a write signal. So watch what happens when I click on write signal. Now it says parent-child write signal. Pretty cool, right? So that's an example of a nested route. So inside of this page, we have this outlet with additional links. And when you click on it, it swaps out that content. Now we're going to turn our attention to actually working with this parent-child write signal. We're going to come across a lot of Leptos and Rust concepts in these demos. So these demos are going to feel like they take a little bit of time to walk through, but what we're getting ready to discuss is really fundamental to building a component-based UI. You have to know how to manage data, how to pass functions down to child components, how to call those functions, to pass data back up to the parent component. If you are in a React class or an Angular class or a Blazor class or a Svelte class or a Solid.js or a Vue class, this is like a big part of what that class would be about, is how to build these component trees. So we're going to take a look at how to do this now, 3 different ways using Leptos. Okay. So let's come back over to the parent-child write signal. I'm going to close some of these other files that we don't need for the moment. And this is where we're going to start right here. Okay, so to get started, I want to create some data that will cause the UI to change when that data is changed. This is what we commonly call state in the UI tree. In Leptos, we set up this state, this data that changes over time and changes the UI over time. We set it up using a signal, as we saw earlier. So let's create a new signal here. We're going to keep it simple for the time being. You'll see a more complicated one later on in the course, but for right now, we're going to keep it simple. We'll say set counter, and we're going to do create signal 0 and initialize it. Now, you will notice that set counter is a I32 write signal and counter is an I32 read signal. Whenever Rust encounters an untyped numeric literal or an integer literal, it'll interpret it as an I32. It'll interpret it as an I32. If I wanted this to be something else, like an I16, I can use the turbofish syntax on create signal. You'll see that create signal is a generic. I can use the turbofish syntax to explicitly set that type to an I16 or a U16 or whatever you want. So if you wanted, let's say, an unsigned integer, a U16, okay? So you can use the turbofish syntax to set that type. So use the turbo syntax to explicitly set the integer type with create signal. And that's just a Rust thing, by the way. Create signal returns back a tuple. So this structure you see here, this is called a tuple. This is the first element of the tuple. This is the second element of the tuple. The first element is going to be a read signal that allows us to read the data, which has the which results in us subscribing to the data when we read from it. And then the set counter is a write signal, which allows us to update the data. So this is for reading and this is for writing. Now, we are going to create two functions, one to increment the counter and one to decrement the counter. These are going to be created with closures. Okay, so we'll say let increment counter equal to set counter dot update. Update expects to receive a closure as well. It's a function that will execute when the update happens. So we'll just give it a C for the parameter. Now, when I receive this C, I need to dereference it in order to modify the content of it. So to dereference it, I'm going to use the asterisk C, and then I'll add 1 to it for my increment. You will see some red squiggles. That's intentional, I promise. All right, so go ahead and set that up for me. Now, it's telling us to give this closure a specific explicit type for the parameter. We're not going to worry about that for the moment. We're going to be using this inside of our view. And when we go to use it inside the view, Rust will be able to infer that type from where we assign it. So for the time being, we're not going to be worrying about typing out the underscore. I'd like you to take that same piece of code now and change it to decrement and subtract 1. I'll give you a second to do that. Notice that the closure passed to update does not return anything. We're receiving a reference in, dereferencing it, and modifying the data inside the reference. And by the way that I know that I'm receiving a reference is you'll see the ampersand here. So the ampersand says that I'm receiving a reference, which is a pointer. And the mute is telling me that I can mutate this variable. So I use the asterisk to dereference and access the content of the pointer. And then I use this to actually mutate the letter C, or the variable C. Okay, so now what I'd like you to do is let's go ahead and put a div tag in here, and then a closing div, and then let's add another div like that. So go ahead and put some nested divs in there for me. All right, now that we've got the nested divs, what I'd like you to do next is this. On this div, we can write some styling. So while we typically like to do styling through a CSS file or a library like Tailwind, you can in fact use the style attribute here directly. And I'll just say border 1 pixel, solid, black, and margin 4 pixels. So go ahead and just put a little styling on there for me. Okay. Next step. I'd like you to take this paragraph element, move this inside the div, but let's change this to an H3. And let's just call this parent write signal. So go ahead and add that paragraph tag into the div like that. The reason we need this is that we're going to show the parent versus a child component that we haven't created yet. So there's going to be a child component that we're going to create here shortly. Okay. So now what I want to do is I want to put in a paragraph tag, and I want to have my counter. And then we're going to use the read signal to reference that counter here in our markup. And then we're going to add one more div here. So go ahead, put the paragraph tag, use the counter read signal. Think of that as a read signal. When you put that into your template, it's going to cause the this view to become subscribed to the counter signal. And so when that counter signal changes, it'll know to update this part of the UI. The big difference between this and something like React, or even like Blazor, is that React and Blazor, they have state, and when you modify it, you re-render, like you just re-render the whole tree. In the case of signals, like you see here, signals don't have to re-render the whole tree because they remember which part of the view where the signal was used. So there's a little bit of magic going on behind the scenes so that it knows which part of the view is using that signal, and then that part of the view just re-renders itself. You don't have to re-render the whole thing. Okay, so now that I've got that div, now we're going to bring in a button. We're going to wire up the on-click event handler. We do that with the on::click syntax. And then I'm going to assign increment counter. And then I'm going to come into here, and I'm going to say parent plus 1. Now, you'll notice once I assigned the increment counter, notice the red squiggle on the underscore went away. And the reason that went away is because it now knows what the type of the underscore is. The type of the underscore should be a mouse event. Yeah, because when this function is invoked by the onClick event handler, the web browser will pass in a mouse event object into the pass the mouse event object into the event handler. And because it can infer that from its usage, we don't have to be explicit up here. Okay, I'm going to copy this again, and we're going to say parent -1, and we're going to say decrement counter. All right, now you'll see we have more red squiggles. But go ahead and add that button, and then we'll take a look at what the red squiggles are. Okay, so I'm going to mouse over this. All right, now we have encountered the memory safety stuff. The borrow checker is giving us some information here that we need to know about. It's going to tell us to force the closure to take ownership of set counter, and that we should use the move keyword. So let's talk about this here for a moment. What exactly is a closure? I mean, we've defined a closure as a function, like we get that part. But what makes a closure function different from other kinds of functions? A closure function is able to make use of its surrounding context inside the function itself. So for example, in this case, the surrounding context is this counter and set counter signal. We're utilizing set counter directly inside of here, okay? Now here's the funny thing about it. If you come from other programming languages like a Python or a JavaScript or even a C#, you don't really think twice about referencing this set counter inside of here. This isn't something that would cause you any concern. But if you actually start to really look into how memory is managed, if you were to look at something like the C programming language, and you start to understand how the stack works and how things are disposed of on the stack when a function finishes executing, you'd start to realize we have a little bit of a potential problem here. Let me see if I can kind of explain this in very high level terms. When this parent function is called, something called a stack frame is created on the call stack. On that stack frame, all of the variables that you see here are defined. So if you were to look at the stack frame, you'd see a listing of variables and whatever their values or pointers to values are. What happens is when a function finishes executing, its stack frame is destroyed. So when we get all the way down to here and this function finishes running, all of the variables that I created up here, they're all going to be destroyed. In Rust, what that means is that basically anything on the stack frame or anything pointed to on the stack frame is going to be dropped from memory. We have a problem though. When we go to render this element tree out, we're passing references to these functions. These functions also have a dependency on create signal, on the counter and the set counter. So if I pass these references to Leptos to then wire up on the DOM tree for me, But all of this is going to be destroyed when the parent function exits. Then I'm going to have a problem, because when I go to click these buttons, guess what? It's not going to be able to run this code because it doesn't exist anymore. In a language like JavaScript, this problem is solved because JavaScript knows that you have a closure reference. And so JavaScript keeps these variables, keeps the stack frame in memory on the heap, so that later on, if you need it, you have access to it. And then eventually the garbage collector in JavaScript will clean it up when it's no longer needed. But we don't have a garbage collector in Rust. Rust is having to enforce all of these rules at compile time. And at compile time, it's deciding where to drop things, basically. So how are we going to solve this? Well, first of all, we are assigning these function references to the onClick. This is just like passing any other value in Rust or any other variable. These functions, their ownership is going to be transferred to this code. So even though we're going to lose these variables, the functions that are defined here, their ownership is going to be automatically transferred here, following the same ownership rules that you have in Rust. If you call a function, you pass something into it that's not a reference, that function takes ownership of that thing. If you're curious about how that works, check out some of our earlier webinars where we went over memory safe programming, and we show examples of calling a function, and the function that you call takes ownership. Our real problem isn't so much the increment and decrement counter functions, it's this set counter. What's happening is, because we're referencing this via closure, this closure is not taking ownership of set counter. Because the closure is not taking ownership of set counter, when we pass this function in, we might be transferring ownership of the function, but set counter is not going to exist anymore. So what we're going to do is we're going to tell Rust to move set counter into each of these closures that we have here. And so this is going to move ownership into this closure and into this closure, so that we can still reference set counter later on. Really, there's an ownership mechanism happening here as well. Okay. But anyways, we're going to use move to transfer ownership of set counter into the two functions. Now, what might throw you off a little bit here is, how is this function able to own set counter, and how is this function able to own set counter? If my understanding is correct, and I could be slightly incorrect about this, if my understanding about this is correct, as part of our component macro that we have here, I believe there's some type of operation occurring here behind the scenes to do some type of RC type or something where we can have multiple ownership, and that's being cloned in. I don't know that for a fact, and I haven't dived deeper into Leptos to research how it's allowing multiple ownership. It could be a different mechanism, but ordinarily something has ownership exclusively unless you bring in something like RC or ARC or whatever, and then you can share ownership. I want to say behind the scenes, something like that is being set up here. Because ordinarily, if I were to move set counter into here, I wouldn't be able to move it into here. But I want to say that's working because of some type of RC mechanism. And maybe when we do the expand macro part later on, we can actually double check that code and see what's happening behind the scenes. But if there's a part of you that's saying, well, wait a second, if I move it into here, then do I really have access to it here? Right? You notice we're not making any clones or anything like that explicitly. Usually when you work with closures and you move stuff in, you make a clone of it first, unless it's going to have exclusive ownership. So because write signal is a copy, when we move it into here, the move will make a copy of it automatically for us. Whenever we're working with things like strings and stuff that don't support copies, you have to make a clone. But in this case here, because write signal is only on the stack, it can make a quick copy of it, and so we're getting a copy of it each time. If you're working with something that you can't copy, then you have to clone it if you were going to have multiple ownership and bring in like the RC type to do that. Cool. Thank you for sharing that. Okay. But I will also mention this. Because of our use of macros here, even though it's using a copy, it would have been possible for it to do other magic behind the scenes. I mean, after all, it's going to literally interpret all of this into Rust code. So there could have been other magic behind the scenes, but the write signal as a copy makes a lot more sense. Okay, so there's our parent. So now if I were to stop this and run, and we come back over to here and refresh this. All right, let's see. I'm incrementing and decrementing, and it's not doing anything. So let's see what's going on. So if our code doesn't work, I'll open up my console here, and let's take a look here at the error that we're getting and see if we can see what's going on here. I think I left it as unsigned, didn't I? Let's go back over to our code and let's fix that real quick. Let's make that an int 16 so I can go negative with it. So if I do that and come down to here, stop my server and restart. Okay, so now we'll come back over here and refresh this. There we go. Just make sure we don't have that unsigned type, because if you try to go negative on it, it'll overflow. Okay, cool. So there's our parent write signal example. So we covered a bunch of concepts there as part of that discussion. Everything from setting up the actual code to discussing the concept of moving and things like that. Now, what I want to do is I want to have a child component, and I want to make the child component be able to update this same counter. So let's come above the parent component here, and let's say component pub function child impl into view, and then go ahead and have your view macro, and we'll do a div to get started. So I'll pause here for a second. Go ahead and add your child. Okay. Now, our child is going to need to receive the read signal and the write signal if it wants to be able to modify the data. So what I'm going to do is I'm going to add a couple of parameters here. You could call these props over in React, inputs in Angular, parameters in Blazor, if you're familiar with Blazor. We're going to say counter, read signal, and in this case, our read signal is going to be for an I16. And then we're going to have set counter, which will be a write signal for an I-16 as well. So go ahead and add those two parameters to our function. So we have the ability to literally pass the read signal and the write signal directly to the parent here, or I'm sorry, directly into the child from the parent. Now what we're going to do is we're going to take the logic we have down here and we're going to copy this. So we're not going to retype it all out, and we're going to paste it like this. But we're going to remove the outer div, and we're going to change this to be child. So go ahead and update that to be child instead of parent. Copy that up. You don't have to retype everything out. And we're going to display the same data here in the child. We haven't called the child yet. We're going to call the child right down here. We're going to say child, and we'll do counter equal to counter and set counter equal to set counter. And that'll reference our child component. We can reference it down there. So go ahead and call the child from within the parent. So we can take these signals and just pass them down directly. And sometimes you will want to do that. This is just one of several ways we're going to do this communication. This is just our first example. All right, so if you go ahead and run the code, I'm going to stop mine and run it again. And we'll come over to here and we'll refresh. So now if I increment the child, see how the parent updates too? If I update the parent. So both the parent and the child are updating themselves in response to changes to the counter. And both the parent and the child, because they both have access to the write signal, can make those changes directly. Now the parent owns the value. Like, and I mean, I shouldn't use the word own in with Rust because that gets confusing. The signal is in parent. Okay, so we did not create a new signal inside of child. The signal is in parent, but both of them have the ability to read from it, and both of them have the ability to write to it because we pass the read and write signals into the child component through its parameters. All right, go ahead and run that on your end. I'll give you a minute or two to do that. And then we'll go ahead and set up the next demonstration. And then we'll take the lunch break and then come back after lunch and continue that next demonstration. Okay. What's the good and bad of this approach? Well, for something simple like this with the counter value, the good is that this is very easy to do, very easy to set up. The bad, though, is this. We don't really have any control over how the counter is set. Whether it's the parent or in particular the child can modify that counter to be whatever it wants to be. What if the parent had additional logic that it wanted to implement to control access to its signal? Well, here, by giving the right signal directly to the child, the parent doesn't have control. For very simple things, especially components that always work together, maybe that's okay. But if you were building a complex component system, you were building components that, you know, could work together, may not work together. Maybe you're using another component and putting your own component as a child of it or something like that. You might want to have more control over this state data, over the signal data that we're tracking. That's what our next demonstration is going to enable us to do. So what I'd like you to do is to create a new Rust component called parent-child callback.rs, parent-child callback. Let's go ahead and bring in our initial Leptos stuff and build ourselves an initial parent function. And this will be our parent. And then we're just simply going to have view. And then we'll just have a little paragraph. We'll call this our parent child callback. So go ahead and add that initial component for me. Okay. Next step. Let's go over to our mod rs and parent child. And let's say pub mod parent child callback. Go ahead and register that. And then we're going to have to go back over to app rs and bring in the new component. We don't have to modify the mod rs and components. We don't have to modify librs, but we will have to modify the app to bring it in there. So let's go ahead and open up our app rs file. At the top here, we'll go ahead and bring in our parent child callback. We'll just call this parent callback or parent as parent callback. And there we go. So go ahead and put parent child callback, parent as parent callback, and then we'll scroll down and add that to the routing. And then we have to update the menu on parent child home for this component. Now, what would happen is in a real class where we had like more time, not just this one day thing, but we had multiple days, I would actually have you just add this completely on your own to practice going through the mechanics of wiring everything up. But we're going to do this together just because for the sake of time. All right, so there's that. I'm going to scroll to the bottom down here, and I'm going to add a new one called callback. and say parent callback. Go ahead and add the route for that. Okay, so now that I've got parent callback, now I'm going to come over to parent child home. And I'm going to go ahead and add in the additional menu item here. So we'll say callback and callback. So we added the path and added the menu link in the parent child home. Once you've done that, go ahead and run it again and just verify that everything loads for you as expected. And then we'll start implementing some new code. Okay, cool. Next step in the process. I'm going to open up the parent-child callback and split the screen here. You see our parent-child write signal? I don't want to copy the child, but I do want to copy the parent. I'm going to copy the parent over to here and delete the reference to the child. So down here at the bottom, I got rid of the reference to the child. So I'm in the parent-child callback. I copied the parent component from the write signal into the callback and remove the reference to the child. Everything else is the same. Go ahead and make that change for me. Save it, run your project. I'll give you a minute to do that. I'm going to run mine in just a moment. What's going to be different in this demonstration is how we implement the child, but the parent is actually the same for this. Oh, and if you could change this to be parent callback, just so we know we're looking at a different one. I'll give you another 30 seconds, then I'll run mine. And then we'll open it up to any questions people might have before we go off to lunch. When we come back from lunch, we're going to finish up this demonstration. Then I have one more for the parent-child. And then we're going to jump into working with Color Tool. And we'll set up a little database. We'll copy and paste some data access code around, and then we'll get busy with the implementing of Color Tool for the rest of the class. All right, let me go ahead and open my terminal here. I'm going to stop. I'm going to build that again. The Leptos serve is way faster too for compiling it than the watch is. All right, so let's rephrase. Let's not refresh. Let's not rephrase. Let's refresh. Okay, so now I've got my callback link. Although that looks kind of weird. Let me do this. Let me go back over to my code here for the home. Did I make a typo? Oh, I did. Look at that. I should have put it in its own little list item. Let's pull that out and put it in its own little list item. That'll look a little better. Stop and run. Okay, back over here, refresh. Okay, so now I'm going to click on callback. I should see parent callback, and everything works as it did before. When we come back from lunch, we're going to implement the child part of this using a callback type instead of a signal type being passed through. As part of this, we're going to learn about the into macro, where it'll allow us to pass a closure that will be automatically converted into a callback mechanism that can then be used from the child function. And the nice thing about this is we'll be able to control the logic in the parent component, and the child component will just call the callback function it receives, but it won't be able to modify any of the logic of that function. Okay. All right. Any questions from anybody in the Q&A? We've got about 3 minutes here until lunch. I'll give you a second to put any additional questions you might have in there before we take our lunch break.